This
Anji, can you
conference
please?
will now be recorded.
Thanks, Anji. Yes, guys. Uh, is my screen visible? Can you guys see my screen?
Yes.
Okay. Okay. So we are in the last week of the supply planning module. So today we'll be touch basing on the supply optimizer and some scenarios in the optimizer today. So just a recap, guys. So I think I think not all of us are present in the I think the last session. So if you guys have missed the sessions, please refer back to the you know recorded sessions. So under the supply planning, we had gone through the heuristics, and we had gone to the this is a supply heuristic. And the second type of algorithm that we have seen is a supply propagation heuristic. And then we are in the optimizer now. So in the heuristics, we have seen various scenarios, and then we also have seen the different master data that are required to configure a supply chain. All the all the resources, all the production source headers, which holds the BOM details, and then the three sources of supplies: customer source of supply, a location connecting to a customer shipping a particular product, location source of supply, the transportation lane which connects two different locations, could be a plant and DC, or a DC and a warehouse, and etc. And then the production source of supply, which says that how production happens inside a manufacturing facility. So there we also give another key attribute that is called a source ID, which is a production version number. So once we load all that data, so what we have seen is, so this if this is a network that we make, just a recap, guys. So I make a customer called Amazon. I make a product called S12. Then I create three locations called as a plant 101, plant 102, and warehouse. Then I maintain a customer source of supply connecting warehouse to Amazon. And I also specify what is being sourced, that is S12 product. And then I maintain two location source of supplies, that is plant 101 to warehouse. Again, specify what is the product. And then plant 102 to warehouse, again specify another product. Then I'll do the location product master data, where I extend the products to the locations. All the components, semi-finished goods, based on the supply chain network, we extend the products to the relevant locations. Usually warehouses get the finished goods and plants get all the semi-finished goods, and etc, etc. Then we maintain the production source header inside the plant 101 and plant 102. We also maintain the resources R1, R2. We can also maintain a storage resource at a warehouse, and also a handling resource called H1. Once we are done with the resource master data, we have to extend the resources to locations, extend R1 resource to plant 101, extend R2 to plant 102. And while you're extending, we'll also specify what is the available capacity at the R1. So if we go with the time denomination, like we'll say that 24 hours is available, 24 hours is a capacity available for R1 in a particular day, or 168 hours in a week. And then we map the source IDs to the resources, right? For example, here in the plant one, there are two resources called R1, R1A. Okay, and then for the S12 plant 101, to make the S12, there are two production versions, PV001, PV002. Then we assign the production version to the right resource. And we'll also specify this source ID, this production version, how much of capacity it will consume to make each unit of this source ID. That is called the capacity consumption rate. Once you load all that, and once you specify that this product S12 at Amazon location on a particular week, if it has a demand of 10,000, the demand is 10,000, and once you run a supply planning algorithm, it will push the demand of 10,000 to this supply chain network, and then it will come up with the outputs of how much production has to happen. That's the first output. So that how much production has to happen so that I can supply 10,000 units of the product S12 to the customer Amazon. Next is how much of the transportation plan has to happen. How much the plant one has to send to warehouse, how much plant two has to send to warehouse, and how much warehouse has sent to Amazon. We also get the purchasing plan. So this is a simple network. There are no components that are being supplied by the vendors. If we also specify it, we'll get the purchasing plan. And then we'll also see the stocks across your network, that how much the plant one has to keep as a projected stock for future, how much the warehouse should hold. All the stock projections we'll get, and then also we'll get the capacity picture, that how much of the capacities were being consumed to produce this 10,000 and to ship this 10,000. So these are the major outputs that we get with the supply planning algorithms. Okay, and now with the supply heuristics, how they function. Supply heuristics function with the quotas, right? We have to give a quota. Here the warehouse has two options. I'll give zero point 0.5 to plant 1 and zero point 0.5 to plant 2. Then the demand would be split as per zero point 0.5 and zero point 0.5. We have also seen, if I mark the time series indicator as X in the sources of supplies master data, then the planner can maintain time dependent values across the horizon. If we want the algorithm to read the quotas from the master data, we just have to maintain the master data attribute, that is called location sourcing ratio. But if you want to change the ratios as per the time frame, quarter one I want to give high priority to plant one, quarter two I'll shut down this plant 102, I'll maintain the quota as 0 there. So accordingly, for that we have to specify that this is a time series indicator. Then we can play with the quotas. And then we have also seen different things inside the heuristics, how the in-house and external production happens, and uh, and then majorly the supply heuristics, the kind of a key takeaway is that this is infinite supply plan, infinite demand and supply plan without any shortages. So this is a kind of a, you know um, the unique identification of the supply heuristics. Why you want to run a heuristic? Because I just want to run my heuristic so that I'll in a scenario that I want to meet the demand, and if and I don't care about the demand, if even if it is 1,000 or 10,000 or a million, I will meet it. And then the heuristic will come up with that supply plan, and it says that the 10,000 can be met, and to make the 10,000, this plant has to do this much, this warehouse has to keep this much stock, this much of transportation has to happen, etc., etc. But there the heuristic will give the negative values wherever there is a shortage, because if the demand is 10,000 but the uh, you know uh, 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 for example, if the supply has reached only 9,000 but still system says that ship 10,000, and what happens to that the remaining 1,000, that would be, that shortage would be projected as a negative projected stock, so that the planner can go and see what's going on in my supply chain network. If I want to meet all my demand, where all I'll get these bottlenecks, where all I'll get these, you know It's kind of alerting situations so that he'll go and plan it accordingly. Second type of algorithm is a supply propagation heuristic. It is just like the heuristic. I mean to say that it also works on quotas, and all other things that are there in the heuristic also be covered in the supply propagation heuristic. But only thing is that this is not an infinite supply plan. This is a finite supply plan with shortages. That means if there is any shortage, heuristic will not give. If like, again, same example, the demand is 10,000, I can only get 9,000. System only sends 9,000, and then the shortage would be of 1,000. So with this, we'll know what customer demands will not be met, uh, and in what buckets, and etc. And again, this works on quotas and the other stuff. Okay, now we are in the optimizer. We have also seen a lot of scenarios on yesterday about there are three kinds of constraints. So now, question: the low level code in IBP, how is it determined? Every planning run, it's a separate job, mm, or it's a separate job, or both are possible? Not sure of what is this low level code in IBP. Funny, can you please elaborate on that? But yes, running the jobs, we can schedule the jobs. There is a particular app called application job. Now we'll say it. It will come in, I think, in another 3 4 days, where we can schedule a job, and we can also make it as a recurring job. And then it's kind of a process chain in in the APO language. Here we can also bundle different operators together and then run it, schedule it, and then we can go and see whether it got successful or not. But it would be more on Fiori interface. So that is there. And also planning runs, yes, we can open the planning views and can here in the advanced run, you pick up the operator that you want to run, pick up the SNOP operator, and under it there might be different profiles that were configured. So pick up the profile that you want to run, a profile for heuristic, a profile for the optimizer, etc., etc. Pick up the this thing, and then to run it. And then also when running it, you can very well keep some filters and can run it only for a one particular brand, or maybe for a particular sub network. Then you can get the results. So yeah, I think if that is your question, not sure whether I have answered it or not, but yeah, please feel free to type in the there. So yes, guys, so what I'm trying to say here is that there would be constraints in our supply chain, right? So for example, we don't want to stick to the systems result all the time, and we want the system to respect the constraints that are there in our supply chain. And then when we specify them, our algorithms has to respect it. So heuristics, propagation heuristic, optimizer, they all respect the constraints. And we have seen in the last 3 days, we have spent some time on introducing these constraints, the constraints in our supply chain network, and then we get the desired result that we want. For example, quotas is some kind of a constraint, right? So because in some period I can say the quota is 1, and for one plant, for plant 2 the quota is 0. That means I'm putting a condition to the algorithm that push all the demand only onto the plant 1, because plant 2 I gave the quota as 0. That means I don't want to do any production activity in plant 2. So that is kind of a constraint, right? So, and yeah, so in optimizer the constraints are they'll get exploded. There are so many constraints, and then they are categorized. The constraints are categorized based on the adherence of the algorithm. One is a hard constraint, another is a pseudo hard constraint, a third is a soft constraint. Hard constraint system always respects them, and never violates them, and it gives the solution as per the hard constraint. The pseudo hard, it gets high penalty costs, but still it tries to violate, it tries to adhere to them. But if it is clashing with the hard constraint, it will not respect it. Soft constraints also based on the cost, and higher the cost, higher the adherence. So So as a business, we have to first sit and see what constraints that we have in our supply chain, and we have to prioritize them, and then we have to build our model like that, and then get the desired results that we want. Okay, so today I have listed down some scenarios, guys. We'll go through them, um, and let's see. Hard constraints, pseudo hard constraint, the soft constraint. So hard constraints, I said, constraining production with the plant capacities. Okay. So, so this is a scenario. The supply is computed based on the available resource capacities. A hard constraint to the optimizer run. Resources which are designated as finite will not have a capacity utilization of more than 100%. With capacity constraints, supply might be lower than demand. For instance, the capacity supply does not fulfill the complete demands. After the supply is exhausted, optimizer will push the remaining demand to the other available sourcing location. So let's see a small example on that. So this is our network, right? So there is this warehouse connected to plant 101, connected to plant 102. Okay. Um, so at the warehouse, you see this is a location, and there's this product. Don't worry about it. So there's this ship to location level. These are the planning levels. This is a key figure. So the independent demand at the warehouse. So I haven't gone into the customer side, guys. So I just want to keep this very simple, so that we'll understand the concept much better. So, and as I told, that the demands can be at a customer location, and also at a at just a location itself. So when I say the customer, we have to use a key figure called as a consensus demand. So whatever demand planning activity that you do, you have to finally populate your demands into the standard supply planning input key figure that is called consensus demand. So in the last 3 days, I think we have seen the same. Consensus demand is the main key figure, which holds the demands for a particular product at a particular customer. But whereas with the locations, there is another key figure called as a independent demand. The name itself is saying that this demand is independent of any other customer or any other location. For example, the sales orders are directly hitting the warehouse. So, and then I consolidate them, so that is my demand for week one. Okay. Week one, I have a demand of 1,20,000. Week two, 50,000. Week three, 60,000. So I have two plants with me, plant 101, plant 102. So plant 101, ship to location is a warehouse. So that means in this transportation lane, the transportation cost rate is $1.45. That means to ship a single product, a single unit of product, as per the the kind of base unit of measure we maintain in the product master data, we incur $1.45. But between the plant 102 and warehouse, the transportation cost is point not zero two, point zero zero, point zero. So what are we signifying here? We're telling to the optimizer that this is the cheapest route. Push all the demand to this route and get your supply from this link. So now there's a small thing. Transportation costs are lower between warehouse and one or two locations. So the optimizer will try to push the demand to the one or two location on priority. But the available capacity at 102 will actually result the supply plan. Okay, now we'll see how these demands will be respected. And then just a small thing, guys, that in the 102 location, the it can only do 50,000 of production, and that is available capacity, and then I've maintained some consumption rates, so it can only do 50,000. So now let's see how it happens. One second, I think. My bad, guys. So I'm really very sorry. I think I have copy pasted a wrong slide deck. I think these were some. Yeah. So the demands are 40,000, 50,000, 90,000 at warehouse location. Now let's see how the optimizer will respect the costs, transportation costs, and then the individual plant capacities. So now let's see what happens. So you can see here that the entire demand, see on week one, let's go with the week by week. On week one, what happened? The entire demand of 40,000 is been pushed to plant 102 location. The capacity utilization is 90%. Why it picked 102? Because of the least transportation cost. And what happened on the warehouse week two? 50,000 is a demand. So entire demand 50,000 is pushed to 102 location. Capacity utilization is 100%. That means yes, it reached its maximum. Okay. Now let's see what happens on week three. Week three, the demand is 90,000 here, but the 102 location, the entire capacity gets exhausted at the cheap sourcing location, that is 102. That means it can do only 50,000. And what is remaining now? 90,000 is a demand. 50,000 can be done in 102. The remaining is 40,000. So that 40,000 will be pushed onto the other sourcing location of a 101. And then 101, the production will happen at 102. Now 101 will ship 40,000 units to warehouse on week 3. 102 will ship 50,000 to the warehouse 3, and it meets the demand of 90,000. So this is a key takeaway. Production at plant 102 will be restricted at a maximum of 50,000 units, irrespective of the various costs and demands. That is a key takeaway. Plant capacity is a hard constraint. You cannot come up with a supply plan which will have uh, more than the available plant capacity if you make the constraint as a finite resource. So for example, in the location resource master data, so you can see here, this is a location. Let's filter on our locations. Plant 101, plant 102. The resource ID is RES101, RES102. Capacity supply is 2424. See this column G, this is constraint type. If you mark it as F, that means you are telling it to the system that this is a finite resource. I mean, don't expect infinite capacity from this resource. If you leave it blank, then the optimizer thinks that this is an infinite, resource, and I can do the, any production that I want. So if I make 102 this plant 2 underscore assembler as an infinite resource, the entire 90,000 can be produced at plant 102 itself, and then it will ship that entire 90,000 to the warehouse. And how about the heuristic? Heuristic will anyway don't care, because heuristics is infinite supply and demand. So remember that infinite heuristic will not read the plant capacities. So for the optimizer, the plant capacity is a hard constraint, and then it will respect your things accordingly. Next are the pseudo hard constraints. So the first scenario in the pseudo hard, minimizing the production plan irrespective of the product demands. When this scenario comes in, I have two plants, so based on the setup costs and etc, etc, whatever is the reason, so you'll say that this plant 101 has to produce this much, and I don't care what demands I have, I don't care what other locations are having, I don't care of that. I'll say that this plant has to do a minimum of this much every week. How will I how will I introduce this constraint into my optimizer run so that the optimizer will respect it? Okay, so let's read the theory. Minimizing the production plan irrespective of the product demands. Scenario description. compute supply plans in which production receipts remember these key figures, guys. I mean, whenever there is a key figure saying, so those were the key figures, standard key figures, which were already pre-configured as per the algorithm. So we have to populate values in those key figures. So for example, you know mm, for example, capacity supply we have seen. I maintain the available capacity there. So, you cannot create a different key figure like available capacity and then you maintain values there and you tell the optimizer to read values from this custom key figure that I maintain, that is available capacity. And let's say that available capacity can have a complex key figure calculation that it is summation of x plus y minus z into k plus t, etc., etc. But after the end of the calculation, so the result of the available capacity has to be loaded into the standard key figure called as a capacity supply. Okay, so whatever key figures you guys are seeing it here, take them as a hard thing that we have to use only those key figures. I think the people with APO background, they'll understand it. So, and I'll share the entire list of the inputs and outputs of a supply planning to you guys, so that when you guys will have all the key figures in handy, and then also keep a track that SAP is keep on introducing new key figures. That will respect it. Hey, sorry guys. Yeah. So, yeah, where were we? Scenario 2.1, minimizing the production plan irrespective of the product demands. What is the scenario? Compute supply plans in which production receipts, which is the production plan, output of the optimizer, are equal to or higher than minimum value irrespective of demands. That means you're introducing a lower cut. You're specifying a lower boundary, that the results has to be more than this lower boundary, equal to this lower boundary or higher than the equal boundary. So how to do that? So planners needs to utilize a standard minimum key figures for this scenario. With this, planner can verify the minimum values that will impact the output key figures. Minimum production receipts is a key figure, then this is a pseudo hard constraint, guys. Okay, and violating pseudo hard constraint causes very high penalty costs. So this is at the back end. So because optimize is a cost based approach, so we have discussed elaborately on the previous day. So it always comes up with a cost optimal plan. What is the most cheapest way of meeting this demand, and I'll follow it. Okay, so that is a thing. So how these pseudo hot constraints are configured in the backend is that system gives a very high penalty cost, so that way system will try to meet the pseudo hot constraints that are there. So these are the wrong slide, guys. Don't look into it. So I'll update them, and I'll you know this thing. So mm, okay. Now there is this key figure called as a dependent location demand, which is output of the optimizer, which says that how much of this location 101 has the demand on week one, and on what location that this depending upon to its connected networks. If the plant 101 is connected to warehouse 1, and then it is connected to warehouse 2 and warehouse 3, and all these three warehouses will push some demand onto this plant 101 for this product called S102. And how the warehouses will push the demand based on the customer that they are connected to. If all these three warehouses are connected to Amazon has some big demand, you run the supply planning, that Amazon demand will be pushed onto warehouses, and the warehouses will further push that demand onto the plants. So that dependent demand, will see it in this key figure called as a dependent location demand. So and then on week one, the dependent demand is 20,000. Week two, it is 25,000. You have to the demand is 25,000, 20,000 for this product called S12. And then there is a particular source ID called plant 101 underscore S12 underscore 001. production version 1. So I have maintained the minimum values as a 35,000 and 40,000 on week 1 and week 2. Okay, this is an input, this is an output, and then this is also an output, production receipts. So now let's see the this thing. Week 1, as the minimum production receipts is 35,000, production receipts becomes 35,000. What is the key takeaway? Though the demand is 20,000, system will stick to 35,000 and will result the supply plan accordingly. Okay, so okay, the demand is 20,000. You introduce a constraint called 35,000. Optimizer did a production of 35,000. But what happens to the stock transport plan? So that depends upon your supply chain, how you have configured other key figures. For example, what it does. So let me give it to you guys here. So let's say what it does is, let's just say that this plant 101 has the least inventory holding costs. Now what it does a transport supply of 20,000. That means the demand is 20,000, I'll ship 20,000. What happens to the remaining 15,000 then? That 15,000 would be seen in this key figure called as a projected stock. Okay, but if you say that the plants will have the high inventory holding cost rates, that means the quantity of the product for single quantity of product, how much cost you incur to put it. So if that is the highest here, so what system does is it ships everything. It ships 35,000 here and it projects nothing, so it makes sure that it doesn't have any stock lying in the location of plant 102. If the warehouse 1 has the least inventory holding costs, it will ship the entire thing to warehouse 1 and it will project that remaining 15,000 in warehouse 1. If warehouse 1 is also having a high inventory holding cost rate, system will try to read where else I can keep this extra stock of 15,000. This planner has given a constraint and he maintained the minimum production receipts. I stick to it. I did extra production and I have this extra stock. Where should I keep it? In what location I should keep it? To what location this plant 101 can ship it? Wherever the inventory holding cost rates are low, it will send it there. Okay. Yeah. So yeah, but let's come back to this minimum thing. So what is the key takeaway here? So this is a key takeaway. Minimum production receipts will be respected by the optimizer even if the product demand drops. Okay, that is a key takeaway. Let me I'll just okay, on week 3 the demand again is 25,000. Now I'll say the minimum production receipts is 65,000. Now what system will do? Will it do the entire production of 65,000? Nope, because it has a capacity issues. It can only do 50,000, so system can do a maximum of 50,000. That's it. What is another key takeaway here? Minimum production receipts, a pseudo hard constraint, cannot violate the hard constraint. Capacity supply is a hard constraint, so it cannot mess up with the available capacity. Okay guys, you guys with me? Is it going over your head, or I'm not sure? Some response, please.
Yes.
Anyone? Is it okay? Can we proceed?
Yes. Go ahead.
Great. Let's continue to the other constraint now. The other constraint is fixing the production plan irrespective of product demands. So what we have seen earlier, it is minimizing. That means you're putting a lower cut, a lower boundary. Uh, you want system to do minimum of this much. And there's also another key figure called as a maximum production plan. So there you can set a maximum limit. So system would play between this min and max. So you have this minimum production receipts and maximum production receipts. Same is the case with transportation. Huh? Minimum transport receipts and maximum transport receipts. How much the stock has to move between this transportation lane. So there's another thing called as a fixing the production plan. That means adjusted key figures. I think if you guys have remembered, we have seen it extensively in the heuristics run, right? So we have given an adjusted a value, and then system respects it because adjusted means a planner is adjusting. He wants to adjust the output. So but the SAP thought that let's not directly adjust the output, but I'll give you another key figure called as an input. You put the values in the adjusted production receipts. I'll make sure that the production receipts is equal to your adjusted value. Same goes with the transportation. You maintain adjusted transport receipts. I'll give the output transport receipts as adjusted transport receipts. Okay. So now let's see how we fix the production plan irrespective of the product demands. Why do we fix it? Sometimes the planner has more information. Sometimes he thinks that this week I will do just the 10,000 absolute value. I'll keep an absolute value 10,000. System has to give me production plan accordingly after 10,000. The system also has to give a transportation plan based on my production of 10,000. So in those scenarios, we use the fixing the production plan. Manual adjustment that enables the planner to fix the values of production receipts calculated by optimizer irrespective of the demands. Okay. And how? Come to the how part. Planners need to utilize the standard adjusted key figures for this scenario. The key figure set is called adjusted key figures. There's another set called a minimum key figures, minimum production receipts, minimum transport receipts, etc. There's another set called as a maximum key figures, maximum production receipts, maximum transport receipts, etc. And they all are inputs. Planner have to go and maintain it for a particular time bucket for a particular planning combination. Like for example, in here we're dealing with S12 product, and if planner goes and maintains it accordingly, optimizer will respect them. So with this, planner can interactively determine the values of output key figure. Okay, and then adjusted is also a pseudo hard. So we are in the zone of a pseudo hard. So yeah. So now, guys, I wanted to touch base on another important topic that is called a frozen horizon. Okay, so what is the frozen horizon concept? I think many of you guys are aware of it. Um, how should I put it in this? So sorry, guys, I should have made the slides before. Um, this is a location. This is product. This is a source ID. This is a week one, and let's say on week zero, that means like let's say last week, you came up with a supply plan that is plant 101. Inside the plant 101 for the product S12, for the production version PV, production version 001, you said that week 0 has to do 100, week 1 has to do 100, week 3 has to do, I mean, like 100. You sent them through an integration, you send them to the S4 system. Whatever, yeah, forget about it. So you send this plan from IBP system, you send it to S4. So the S4 has taken those values of 100, 100, and then there is a BAPI that we should keep it in the integration so that it converts those 100 into planned orders. Now the planners, if you're sending it to PPDS or maybe to PP system, the planners there will open it, and then they will firm some of the planned orders, and for some they convert the plan to an actual production order. And let's say there is a lead time involved to it, and then the production is happening in some time. Okay, so now from an IBP system, from a planning system, you cannot send the production plan for every week. because that is like on a too short notice. For some, like some periods will be frozen for the production, so that as for system execution system will not accept any last minute changes, or it doesn't want any new plan to be sent by the IBP system. Why it doesn't want a new plan? Because S4 is already busy with the old plan that IBP has sent. S4 has already scheduled everything, and S4 is busy in processing it. So the planners don't want the plan, any new plan within the frozen horizon. That's the first thing. And in all the two I mean, out of the three, in two projects we have done it. I think everyone does it. So first is, during frozen horizon, no new plan should be published by IBP. Okay, guys. So what if after frozen horizon, IBP should meet the S4 plan, should meet the S4 plan by minimum. You agree with me on this? Because S4 has, so like for week 4, S4 has already planned for 100. Now you cannot say the week 4 you do 50. Not possible, because S4 has already planned it. They have already firmed it. So now what is the catch here? So we have to influence the optimizer run to respect the S4 plans. Okay, so how we do it? So this is kind of a standard way, and then also some custom calculations that we have to bring it on here. So let me write key figure here. Okay, so now let's see the now I'm putting all the please follow it, guys, carefully. This would definitely come if you guys are implementing the supply plan, especially if you are into consumer goods industry where too much of supply chain activity happens. Okay, so S4 has already formed a particular plan, and we have to bring that back into IBP in a custom key figure called as a firm production receipt. That means this holds the firmed plan. Okay, so week 1 the firm is 100, week 2 they firmed 200, week 3 they firmed 300, week 4 they firmed 400. Now there's another key figure that is called a open production order. That means the production is already happening. So here there's 50, and then just 100, and then another 100 here. Okay, so this is a plan. This is the S4 plan. It's a scheduled plan. This is not a planned order, guys. This is a firmed one, and then this is open production order that has already been done in S4, and then we bought through the interface. Then every day we bring that S4 plan into IBP, so that the IBP supply plan will respect this. Okay, let's say that this is a frozen horizon. Yes, it could be PPDS, or it could be PP also. MRP run output of, it could be anything. So one second, guys. What I'm doing, want to keep the borders. Yes, I don't know. I am this. This is a thing with me. I have to do everything perfectly. Okay. Okay, so how I'll, what is a thing that we discussed during frozen horizon? No new plan should be published in IBP. This is our first requirement, that in the week 1 and week 2, don't do anything new. Just stick to S4. Have to do that. Remember the adjusted key figures that we talked about? If you specify anything in the adjusted key figure, optimizer will respect it. So there is this key figure called as a adjusted production receipts. So, but so that's a one. And after frozen horizon, what is the requirement? That IBP should meet the S4 plan by minimum, because here firm is already 300. Now, if the output, this is output. Okay. Now, if you say here 50, this is not cool, right? Because the S4 has already firmed 300. Now you're saying produce only 50, and now you're shipping only 50 based on the production that's happening. And now your entire supply chain for this particular combination will have the supply of only 50. Wrong. There's inconsistency in the plan. So what you have to do, you have to do a minimum of 300. And if you can do more, do more. If the demand is like 1000, don't restrict yourself to 300, but you do a minimum of 300 and do remaining 700 based on your cost based approach. If production version 002 is optimal one, okay, then do the remaining 700 in the production version 002, but don't discard this PV001 because S4 has already planned something. So please respect that. So how to deal with that? That there is another key figure we have seen, that is called a minimum production receipts. Okay, so minimum production receipts, it's always the summation of firmed plus open. So here this becomes 150, here this becomes 300, here this becomes 300, here this becomes 200. Okay, so what I'm doing in single word, I am populating the S4 plan in the minimum key figure, so that the IBP optimizer will do a minimum of that much, so that the S4 plan is respected. Okay, so now within the frozen horizon we have another this thing, that this it has to be as same as the S4 plan. So what I'll do within the frozen horizon, I'll copy the minimum values into the adjusted production receipts. System copies minimum on week 1, minimum is 150, it copies 150 into the adjusted production receipts. If I run the optimizer, production receipts become 150, transportation happens based on this 150. Week 2, the minimum is 300, I am populating the 300 into the adjusted production receipts. Run the optimizer, optimizer would be same as adjusted production receipts, so this gives 300 now. Okay, so after week 3, production receipts would be a minimum of 300. If the demand is more, it does more. On week 4, it does a minimum of 200. Okay, now there's another thing. Is there a way to adjust my plan within the frozen horizon? Nope. This is based on the business requirement, guys. I mean, if your clients wants to give highest priority to the planners, because the planners have the highest information, if the planners wants to adjust it, they can very well go and adjust it. But in the last two projects that I have worked, the business requirement, they didn't want the planner to touch anything in the frozen horizon, no adjustments whatsoever in the frozen horizon. But what if on the after the frozen horizon you can do the adjustments? So for that, there's another key figure called as a production adjusted interactive. And guys, just remember, this is only editable key figure. This is only editable. And here, this is grayed out. You cannot do any adjustments. How we do that? There's a key figure calculation that we have to write. When we are dealing with the key figures, we'll see it. How to write a calculation so that in a particular time horizon, will not, make the planner to do any adjustments. Any entry basically. So after week 3, he'll say that the production has to happen 444. Now system would respect this 444. And week 5, you just leave nothing, and then system does a minimum of 200. So this is how we plan, we configure the system, and then we play with the standard key figures of optimizer in such a way that it respects the S4 plan. Now finally, what is it? So I'll create another key figure. So this is the net plan, or maybe you call it as a new plan. new plan for production. So this is a key figure that goes to S4 system for the new production plan. So what should I do usually? So only send the net plan, only send the delta. Okay, anything that is more than what S4 has already planned. What happens on week one? IBP said do 50. S4 has already done a 150. IBP said 150. S4 already have 150. So I'll take the net, the delta. So here it would be 0. IBP sent do 300, but S4 has already had 300. There is nothing new. So do nothing. Week 3, IBP said 444, but the S4 has a 300. What is a net? 144. I'll take the delta into this 144. Now this is what this 144 actually goes to S4 system for planning. Okay, for new planned order creation, etc. So week 5, IBP said 200. S4 has already had 100, 200. There is no new net, so that's why it is. But if the demand is high, if optimizer thought that okay, I'll do a production of 500, so IBP said 500 is a plan. S4 plan is 200. Net plan is 300. So this is what is finally goes to the S4 system through another interface. Okay, so if you have seen it here, we have followed the ground rules. That is, within the frozen horizon, IBP is not giving anything new to S4. There are no last minute changes. After the frozen horizon, IBP is giving something which will be respected by the S4. So I think it might take some time for you guys to just digest it. Uh, but this is how we deal with the frozen horizons. Okay. So this is a calculation logic I mentioned. So remember there are two adjusted here. One is interactive, which is editable. You see, adjusted production receipt. This is actual input to the to the optimizer, and it will respect the adjusted values here. So this is non-editable because there's a calculation in here. What is a calculation logic? Two logics. One is during frozen horizon, after frozen horizon. During frozen horizon, planner input would be nullified. In this frozen horizon, planners are not allowed to edit. But after frozen horizon, planner inputs will be stored. So planners can change the production plan. Now let's see the adjusted production receipts. System copies the minimum values. Minimum holds the S4 plan. After frozen, system copies the interactive values. What is the key takeaway? During the frozen horizon, system will not allow any user adjustments. IBP supply plan will be same as S4 plan. After frozen horizon, planner can make adjustments irrespective of the product demands. That is anyway there. So you give an input, doesn't matter about the product demands, and then it will respect it. So this is uh, this thing. So you can see here the same ones: location, the product, the source ID, the dependent demands are 40,000, 40,000, 40,000, 40,000, but doesn't matter because optimizer gives highest priority to the constraints that we introduce. The minimum is 33,000. How it became 33,000, it is a summation of firmed and open. It depends upon the business requirement, guys. Sometimes they just only look for the firmed, then you map only the firm to the minimum production, etc. So adjusted productions, it is grayed out because in week one adjustments are not allowed during the frozen horizon. We thought about it, why we don't want to allow any adjustments, because we want to blindly respect what is there in the minimum. And what is there in minimum has S4 plan. So adjusted is 33,000, production is 33,000. Adjusted is 44,000, production is 44,000. And I think the interactive here, this is not a 4,80,000 typo. It is just a 48,000. So though the minimum is 30,000, though the demand is 40,000, doesn't matter. Adjustments will get the highest priority. Interactive gets copied onto adjusted. Adjusted becomes the output. That's why you can see here 48,000. Week 4, demand is 40,000, no minimum. Interactively, you said it is 65,000. 65 gets copied onto the adjusted, but will it do 65,000? Nope, because you can do maximum of 50,000. So again, the same thing. Adjusted receipts being a pseudo hard constraints cannot violate the hard constraint, that is the plant capacity. Okay, guys. So yeah, next are the soft constraints that we have. Some 8 scenarios I have mentioned. So let's see them one by one. So first is a demand prioritization based on the non-delivery cost. I'll do one thing, as I'll beautify it furthermore and then add more content, take off the irrelevant content, and then I'll send you the updated slide so that you guys can read it. So non-deliveries, we have seen it already, but just want to highlight it. So the demand is 90,000, demand is 95,000, but the non-delivery cost rate is it's 99,999. So this week I maintain there is no non-delivery. I think we have already covered on what is non-delivery. Non-delivery is the cost that we incur if we don't deliver the product. Hey, one second, guys. Yeah. So I run the optimizer. What happens? This week one demand would be prioritized. Why? Because you mentioned some high non-delivery cost rate. That means you're telling it to the system that if I don't deliver it, I incur this much of cost. So week one I have to do. So that's why plant one did a full capacity of 50,000. Plant two did a 40,000. Total is 90,000. It ships 90,000 to warehouse. That's it. Whereas warehouse week two, it did nothing. No transport, no production, nothing. Why? Because non-delivery is not maintained, and non-delivery is the highest one, and it supersedes all other supply costs. For example, even if the production cost is something, even if the transportation cost is something, doesn't matter. If the non-deliveries are high, it meets the demand. Next, what's the second thing? Demand fulfillment based on late delivery costs. We have seen it, guys. In general, supply planning algorithms, if there is a demand at customer side for week 10, it should meet the demand on week 10 only. It cannot meet the demand on week 11 or week 12 or any other subsequent period. That is ruled out. Optimizer or any supply planning algorithm, if the demand is on week 10, it will meet only on week 10. It might does the pre-building of the stock on week 9, week 8. It projects all the stock at week 8, week 9 or something, but the actual shipment happens on week 10. But what if I cannot do on week 10? Because I don't have that much capacity. So can I do a late delivery? You can do it. There is this option, but you have to specify the key figures for it. So they are called as a maximum late delivery periods, and you say 2 periods. That means system can postpone the late deliveries, the shortages, for another 2 periods. So here we can see the demand is 1,20,000, but we have seen that the plants can do only 50,000, 50,000. That is a full capacity that we can run. So system does the transportation of only 1 lakh, 1 lakh, shortage of 20,000. That would be met. System try to meet them in the another 2 consecutive weeks. So here we can see that. So here you see here 90,000 is a next week, 90,000 is a demand, but it's supplied 1 lakh, 1 lakh, and that remaining 10,000 is belongs to this demand. And again in here that another 10,000 belongs to here. So whatever shortages are there, it would be met in the subsequent periods only if we make the maximum late delivery periods. So see this key takeaway: if the production capacities are not available in a week, not just production capacities, or maybe you introduce something called adjusted production receipts. So you adjusted the production receipt as 1,000, demand is 2,000. You cannot meet that on the current week. You can only do in the subsequent period, right? So that could be also another constraint. Demand shortages would be met in the subsequent periods with the late delivery functionality. What's the third one? Manufacturing location chosen based on the least production costs. I think you know it, guys, so we don't have to get in there. The least production cost would be picked up on priority if you're running your supply optimizer. Prioritizing the resource utilizations based on violation cost rates. Okay, so let's see this. Okay, there is nothing here. Okay, there are two key figures. One is a minimum resource capacity usage, minimum resource capacity violation cost rate. Now, okay, so there is this warehouse connected to plant. Okay, and inside the plant there is a resource R1, there is resource R2. Resource R1 can take PV001, PV002, and 003 and 004. So all gets produced on resource 1. Okay, so system um, system comes up with a supply plan based on the cost and other stuff, but you want this resource 1 to be occupied for a minimum of this much. So if the available capacity is, so this R1 resource, so key figure, you say minimum resource capacity usage. Okay, the capacity supply on week 1 is 168 hours, 24 hours per day, 168 hours. You want the minimum to be there for 100 hours, and then you also give a violation cost rate, right? So you say minimum resource capacity usage violation cost rate. You give a very high cost, that you are telling to the system that on week 1 you do a minimum of 100, and now if you run it, system gives the production receipts that are getting produced on resource 1. There could be 5 products that are getting produced on R1, and if you sum up the 5 products production, that would be equal to a minimum usage of 100. Okay, there's another key figure called as a capacity usage of a production resource. So here you can, this key figure is output of the supply planning. You can open this key figure and then you can see how much has been used out of this 168. If this is the inputs, it would meet minimum of 100. If the demands are high, it would meet 100 star. That's how you can, put some constraint at a resource also. Okay, what is the next? Transportation direction chosen based on the least transportation costs. We have seen it. You maintain transportation cost rate, that is a variable one. You maintain the fixed transportation cost, that's a fixed cost. The cheapest would be picked up, and system does the supply plan accordingly. I need to put some theory, guys. I'll put it and I'll forward to you guys, so that you can have a read. And they are available on Google also. You just can type it and you can have elaborate information on it. What is the next? Soft constraints. Under soft constraint, so why these all things are coming in soft constraints? Because everything has a cost element to it, right? If you have seen it, so if it has a cost element to it and that is editable, you can go and prioritize it accordingly. But whereas with the adjusted minimum, there is no violation cost rate that the user is going and putting it. He cannot prioritize within the minimum and adjusted etc or capacity supply. But whereas with the soft constraints, you see everything has a cost attached to it. For example, here late delivery, there is a cost attached to it. So this late delivery cost rate. So if I'm saying late delivery cost rate for independent demand, that means the cost that I incur if I do a late delivery. So if I give a very high, late delivery costs, and the system thinks that I cannot meet the demand, I can postpone it. For how many days I can postpone? 2 periods I can postpone. But is it worth it? Is it worth it to postpone? How much costs I'm incurring? I'm incurring this much cost if I'm postponing. How much I'll actually get if I do a shipment? That is non-delivery cost rate. And that non-delivery cost rate is just 999. but you are incurring a cost of 4 nines. So system thinks that it is not optimal to do the late delivery. Chuck it, and it will not do a late delivery. So, so what I'm trying to say here is that every soft constraint has a cost tagged to it. It is up to you to prioritize that cost. You give higher cost rates, system does, the supply plan accordingly. So, yeah. So transportation cost rates, you specify what is a cost rate, and then system picks the optimal thing. Next, what is one? Meeting the inventory targets based on violation costs. Okay, again there is a violation. So there is something called as an inventory target. So that is a target that you want to meet the inventory. So the target is 100, so 1000. So this is an input, and there is an output called as a production projected stock. So if you want the projected stock to be the based on the target, so you need to maintain violation cost rate. The key figure name is inventory target violation cost rate. So you give a decent value, and then system would meet it, and it projects the transportation of 10,000. So if the demand at this is let's say 2,000, let's say this is a warehouse, so it receives 3,000 and it supply to customer 2,000. What happens to the remaining 1,000? That comes into the projected stock. Got it? So with the inventory targets, you can influence your supply plan. So even though the demand is 2,000, as there is inventory target, and as it is a costliest one because the violation costs are maintained as at $99 per unit. So system thinks that let's treat the demand as 3,000 and let's bring 3,000 into this warehouse location, and then let's supply it only 2,000 to the customer or any other location, and the remaining keep that as a projected stock. And then there is this 3.6. I think the slides are gone wrong. That is the product shipment between the locations based on holding costs. So you guys remember there is something called inventory holding cost rate. um, I think in previously we have touched based on it. That means system would project the stock at the at the cheap location where the inventory holding cost rates are low. Inventory hold rates are high, that means system would not project any stock in there. Okay, so this is an input to the supply plan. Inventory holding cost per inventory holding per unit of product per period and per location. Okay. Next scenario, production prioritization based on capacity expansions. So we talked about this. Capacity supply is a hard constraint. If it is 168 hours per week, it would be 168 hours, not more than that. But you can actually say that I have additional capacity supply that I have, and then you can specify that uh, I'll do more. So in the location resource master data, say this is location resource master data, that is this location resource you specify, then you say the capacity supply is 24, and then you can see here capacity cycle expansion, you can say that's 10. If it is week, this is 168 hours, and you can say in this week I can do further more of 50. I'll do extra shifts and I can do another 50 of more capacity. And then if you don't want this to be static, you go and keep this time series indicator. Remember this is what we're talking about initially. The moment you make any attribute that has a time series indicator, if you mark it as X, that means system would take the values from the input key figure. There's an input key figure called as capacity supply expansion. So there you can maintain for one time bucket 50 hours, another week only just 40 hours, etc, etc. So two key figures involved, as I said, There is this capacity expansion which you maintain, the extra capacity that you can do, and then the cost rate that you incur. If you do extra capacity, obviously you incur some cost, right? So I think there is some example that I've maintained in here. So independent demand at warehouse is a 2000, 2100, 2000. Capacity supply is 168 hours, 168 hours, 168 hours. But you can do an extra capacity supply of 50 hours on week 1, 50 hours on week 2, 50 hours on week 3. And then you also incur some cost if you do an extra capacity, that is $2, $2, $2. So now what system does? I think what system does is system does a production of 2000 and the usage become 200, because the usage has to be equal to the capacity supply, right? But here it became 200 because it consumed the capacity that is there 168, and then it took the additional 32 of the additional capacity. That's why the usage become 200, and then it did the production of 2000, and then it shipped that much. Same with week 2. It did the production and it consumed the extra capacity supply that is available, and that's it. But on week 3, I think it just did only 168. That means it just consumed the available capacity that is there because the demand is less. Optimizer found it profitable to consume the additional capacity on week 1 and week 2. Why? Because the in non-deliveries are $5, $5, and here it is just $2. So the cost that you incur if you do a expansion is $2, $2. And then there is a production that you incur $2, $2. So on week 1, the total cost you incur is $4 because you're expanding, you require $2. You're producing, you incur $2. That is $4. But what is a non-delivery cost? That is $5. That means non-delivery is the the non-delivery is the highest, so system does the production. But whereas on week 3, the non-delivery itself is $2, but you incur a cost of $4 if you do a capacity supply expansion. And system thinks that it is not necessary to do to consume the extra capacity. I'll just stick to my available capacity of 168, and then it does only 1680 of the production, and then I'll ship it accordingly. On week 3, system incurs more cost. This is a key. It incurs more cost in consuming the extra capacity. System limited the production to its standard available capacity. So yes, these are the 8 scenarios, guys. Just to recap, there is this non-delivery costs, late delivery, least production costs, least transportation costs. Prioritize the resource and make the resource to get occupied for a minimum limit. Product shipment between the locations based on holding cost. The least inventory holding cost location would be picked up and the stock would be projected there. If system does a pre-building or if system does more production, that extra stock has to be will be kept in a location where the inventory holding cost rates are low. Next is inventory targets. You maintain inventory target, safety stock, like whatever, and then that would be met in here. Inventory target usually comes from an inventory optimization module of the IBP, or it could be planner can go and manually maintain that for this product demand variance is high, so I'll maintain a high inventory target, high safety stock, etc. Next is a capacity expansion. So yeah, so these are the scenarios, guys. So hard, pseudo hard, soft. Any doubts? I think I'm yet to cover the lot sizes. So tomorrow we'll cover the lot sizes, and tomorrow, and here we'll take a break. We'll stop with the modules. We'll go into the model configuration, um, and then we'll start, creating an attribute, creating a master data, creating a key figure, and loading data and writing some calculations. Basically, we'll set up a planning area now. Okay, and then once that is done, it might take a week or something, and after that we'll start with other modules like demand module and SNOP and etc. Any other
Okay.
doubts?
Yes, Venkat.
Yes.
So you will show in the system about all these scenarios.
I think some I have already covered, like all the non-delivery, late delivery, etc. Even capacity supply also. I mean, I think you were there, right, Srinivas? Last
Yes.
session also we have seen that. But today I'm just putting up a scenario because yesterday last this thing what we did is we picked up a key figure, we maintained a value in the key figure, we ran the supply planning algorithms, we have seen the results. But here I'm putting up a scenario, so where uh, a particular key figure, how it will impact the entire kind of a supply chain network itself. So I think some we have covered it already in the system. um, but let me know if you guys want to cover me anything in particular. Then tomorrow we can spend some time, and then we can model it, and then. But majority of the things I think we have done it already. When we did heuristics, we have seen a minimum and then adjusted in the heuristic when we run it, and capacity limitations we have seen it, and minimum resource utilization we have seen, and late deliveries also we have seen. So yes, we have covered them in the other sessions.
Okay, man. And in one of the sessions, you told to optimizer respect the MOT types.
Hmm. Yes,
Yeah.
mode of
Yeah.
transport. Hello.
Yeah. Yeah. So where it will be respect?
Yeah, so where it will be placed. So we're being the location source of supply master data. So let's bring over another one. Okay, so this is a master data. It says what is a ship from location in this diagram here. Plant 101 is shipping to warehouse. That is shipped from location. It is shipping to warehouse. And the product is S12. So if you mark mode of transport also, so it happens like this now here. It's called ID. Let's say 001 is for truck, and 002 is for rail, and you maintain these the other two records for it. Okay, and then if there is another mode of transport, you also maintain it accordingly. So now how to utilize that in the supply planning run. So here if I go to the soft constraints under the uh, transportation costs, this one 3.5 least transportation costs, let me pick this up. This is ship from, this is location, and then this is mode of transport, and this is a product, and then this is a key figure. Okay, location is warehouse, product is S12, key figure is independent demand. Okay, there is 1,000. So now let's assume that it has only one transportation lane. Ship from is only plant 101 is connected to warehouse. Mode of transport is truck, and the product is S12. And here the key figure. Now this is where we can utilize this transportation cost rate. If you also bring the mode of transport into the system, and if you include it into your master data and make it as a a key attribute in it, mode of transport ID. So now here you can maintain, my truck is a $5, and my rail is, it is just $1. And then you maintain, for the same transportation lane, you maintain multiple costs for mode of transport. Now system would obviously naturally pick the least mode of transport, and the 1,000 would be pushed onto the rail network, and the system would do a shipment on the rail mode of transport. Accordingly, there is this key figure called as a minimum transportation, or maximum transportation. Let's say this is maximum transportation receipts. So usually it would be at a ship from location and location. The product is S12. But with the mode of transport, you can say that the truck should the truck should maximum do only 400. And then for the rail, I don't care. I'll just leave it as it is. So now if the demand is 1000, system would do a maximum of 400 for the truck. Like, let's say if it is a minimum, I'm saying minimum. So now what system will do is, system will give the result like this: transport receipts, as you maintain minimum as 400, system does a minimum of 400 here, and the other available mode of transports, it's push the other demand, that is 600 is the remaining, right? Because the total demand at warehouse is 1000, and the other one it does 600. So that's how we use the mode of transport ID. And then obviously naturally everything in here will be reflected based on mode of transport. Here there's a lead time. So here this 001 truck, the lead time is it takes 2 periods, but whereas with the rail it is 0. And system would think that if there is a demand on week 1, so I cannot do that shipment through the mode of transport truck, because it is taking 2 weeks to reach. So system optimizer will have the basic intelligence that it thinks that I should pick to the mode of transport 2, so that I can meet the demand based on the lead times that are there. And the lot sizes and all other transportation related key figures we have seen, everything will be extended to the mode of transport ID. I haven't configured that in my planning here. That's why they are not appearing in. But usually, yes, we maintain mode of transport IDs also.
And maybe we are maintaining the MOT types manually. So here also we need to maintain manually.
No, it can come from PPDS system. So the transportation in PPDS. So mode of transports, it would directly come and sit in the the location source master data.
And having a one other query vendor. So for some of the master data, we are having the customer ratio and transport ratio. So that values also will be come from backend system, or we need to
Yes, yeah, if you have that in the backend system, I mean, if in the source system, if you have it, then yeah, naturally bring 0.5 and 0.5 here. If you don't have it, then you can directly go and maintain it.
So for example, for this location sourcing ratio, so in
Hmm.
ECC, field is available to maintain the value.
Yes, I think I lost your voice. But yes, Srinivas. So when you're building up this integration thing, rise of object integration document. So when you're specifying that what is your source table and what is your target table, target would be location source master data, and where you very carefully map everything. So the material ID would become a product ID in IBP. This destination location becomes a ship location ID. Shipping location becomes a ship from location. So when you're mapping all that, if the ratios are maintained in the source system, you bring them into the IBP and then you maintain them accordingly. And these ratios are useful only for the heuristics. And optimizer is a cost based approach. I mean, you can make the optimizer to respect the quotas, but it is not mandatory that ratios has to be there.
Yeah, okay. And when just want to know in ECC, is there any field to maintain this sourcing ratio?
Okay. You were asking about the source field itself. Not sure yet. I mean, I have to look upon it. And yes, I have to look upon. I'll let you know, Srinivas, tomorrow. Let me make a
Yeah.
note of it. Mm, Yeah,
And when one more thing, so in
yeah,
planning,
yeah. Just want to give one small thing here. So in here, if this is a case, if there is location source quota, so what we do is, and then here this is plant 101, this is plant 102. Let's just say this is just the truck. So you, let's say there are no quotas. So how to maintain the quotas and across the periods? So I would suggest open your view at a yearly level. You open your view and 2019, and you maintain the quota as a zero point 0.3 here and then 0.7 here, and then save it. So system does the disaggregation. If you maintain the disaggregation mode as a copy, and if you punch a quota of zero point 0.3 at a 2019 level, And when you save it, now every week will have a value of 0.3. Getting it? So this is another way to maintain the ratios, I mean, easily. So because, like, this is a horizon, and you're running your heuristic or optimizer for like 1 year, and you have to maintain the ratios for 1 year. And then if it is a time series indicator, if you mark this as a time series indicator, that means read the values from the key figure, then you can open it at a yearly level, and then maintain it and then say it. Okay, yes, Srinivas, another doubt, please.
Planning area, we are having the hundreds of key feeders. So for which module, which key feeder we need to use that based on our practice only we came to know that.
Yes, and then also you can reach out to the product documentation of SAP, and there you can see. But whereas for the demand planning, there is no standard input, standard output for the statistical forecasting. We can specify the level that we want. So if you want to do the forecasting at brand level, create a key figure at brand level, and then use it as an input, and the output also at brand level. So, but the supply planning algorithms and the inventory optimization algorithm, there are standard set, and you have to use it to the standard set. For supply planning, I'll share the key figures, which are the inputs, which are the outputs. And then so based on that, you can be aware, or you can reach out to Google or IBP product documentation. I'll give you some links, guys, in some time. So and also some documentation where you can directly refer those, the key figures, and what are the inputs and outputs, and which key figure belongs to which module. And it might, Srinivas, just to add thing, it might not be straightforward. We struggle a lot, right? Even for also, if we want to understand any field, we have to spend some time, dig deep. It's not like a straightforward, it will directly be visible on the screen that, okay, use this, it will do XYZ, it will impact XYZ, end of the story. It will not be like that. We have to obviously burn the midnight oil to understand all this set of key figures.
Yes, Vendor, you are right, and already I am doing that one only.
Sure, great. And Srinivas, whatever you have just listed down, and then please reach out to me, and then send an email or put it in the group itself. We'll all will discuss, and everyone will get benefited based on your doubt. So any scenario that you're working on, bring that out, and then we'll discuss on it.
Yeah, Vendor, is it possible for you to share your mail ID?
Nope, not possible. Against the rules of global online training. So everything has to be done through the meeting coordinators. And that's a clear-cut instruction that I have received on it.
Yeah, okay. And when actually SAP, IBP, SAP, they are giving us some standard template for demand SNOP, right?
Yes.
So, but when I'm going through that one yesterday, the template which we are showing in the previous sessions, and though having the some of the in there, I am
Yeah.
not seeing the figures.
Exactly. So, I mean, as we have seen, like planning views are editable. We'll have another session also, how to, customize the planning view based on our needs. And then, like the templates that you have opened, it might be having a 6, 7 workbooks, right? So it need not be 6 workbooks all the time. It could be just a one workbook, and then at a level that you want. So we can do that, changing. So there's another session coming in. So, and then we will see it there, how to change the planning views and make them as customizable.
And is it possible for you to share the supply template which you are showing?
Supply, it's already there, right? I think in your, if you have the IBP access in your planning area, it would be available there. It goes with the name of SOP, supply planning, I think.
Yeah, there, but actually there. For example, for demand, they are doing the only one key feeder only. But in our sessions, you are added the some more key feeders for different sheets also. So just I want to go through your session.
Oh, okay. Sure, then yeah, I'll download the template that I'm using in. I'll send it. It would be just a simple Excel sheet, but once you log in and then once you do a refresh, then the Excel sheet that I have sent will be established with your planning area configuration. Okay.
Yes, and already I'm doing. I did that one.
Great. Great.
Thanks, Chandra,
Any
for
other
working.
doubts, guys? Sure. Yes. Thanks, man. Any other doubts, guys? Okay. I hope you guys have learned something with the optimizer, and I know it has more to digest. But yeah, at least you have the feel of the optimizer and know the the high level things. And tomorrow I'll touch base on the lot sizings, and also the aggregated planning, that I want to touch upon. So because till now we are introducing constraints at a detail level, right? If it is a transportation cost, we are saying, if it is a minimum production, we are saying, we are going in detail and we are specifying that what is a manufacturing location, what is a product ID, and what is a source ID. Also we're going into that detail level and we're introducing a constraint. But there are aggregated constraints where you keep a constraint at a very high level and still optimizer can respect it. And if we use it nicely, here our consulting thing comes in, the value that we bring onto the table. So the way you model these constraints is the actual real big deal. So yeah, so there are other topics also, I'll bring that up. But you guys have got the feel how systems work and how the demand propagates, how the constraints would be respected. um, um, mm, yes, so yeah, thanks Fanny for that. So yeah, so you guys know the theory, and you guys got the feel. If anything is there, you can please reach out to Google and type SAP space IBP and then your dot, and I'm sure you will get lots of this thing, because you might get a different requirement, or you might be, your business case would be unique. And the thing that you're trying to achieve could be as unique as per the business. So yeah, now at least you guys understood like how in general the optimizer works and what kind of a constraints are there, and how I can introduce these constraints and get the desired result that I want, and then how we can influence the algorithm in itself, the heuristics, propagation heuristics, and the optimizer and the master data is available. So yes guys, tomorrow we'll start with the modeling. Tomorrow we'll spend some time on the optimizer, lot sizing procedures, and aggregated constraints, and quickly we'll get into the configuration. We'll start from the scratch, attributes, master data, key figures, time profile, everything, and we'll build the model. And yeah, so that's it. Have fun guys, that's it. Thanks for joining. Bye.
Venkat.